Utility Part 2. We shall start from where we stopped in Part 1 of this tutorial. Consumer consumes good X and good Y. Income of the consumer is 50 rupees. Price of good X is 10 rupees. Price of good Y is 5 rupees. Utility schedule is given. The central idea of this lesson is consumer equilibrium. How does a consumer reach equilibrium when he consumes more than one good? Well, we shall find an answer for this question here. Consumer is in equilibrium when he maximizes his total utility by spending his entire income. For this, the following conditions are to be satisfied. First condition: marginal utility of good X divided by price of good X equal to marginal utility of good Y divided by price of good Y equal to marginal utility of money. Second condition: at equilibrium, the marginal utility of good X and that of good Y must diminish. Third condition: amount spent on good X and on good Y must be equal to his income. Algebraically, it can be stated as Px multiplied by Qx plus Py multiplied by Qy equal to I, where Px is the price of good X, Qx is quantity of good X, Py is price of good Y, Qy is quantity of good Y, I is the income of the consumer. Px multiplied by Qx is the total amount spent on good X. Py multiplied by Qy is total amount spent on good Y. Now we shall go to the utility table we have developed earlier. Remember, the consumer has to equate MUX by PX with MUY by PY. In the table, look at the column MUX by PX and MUY by PY. These two columns represent the marginal utility of 1 unit of money. The consumer proceeds like this. He consumes 1 unit of both the goods. Marginal utility of Y divided by price of Y is greater than marginal utility of X divided by price of X. He has to reduce the marginal utility of 1 unit of money spent on good Y. So he has to consume more of good Y. He consumes the second unit of good Y. The new combination consists of 1 unit of good X and 2 units of good Y. He compares MUX by PX and MUY by PY. They are equal. He examines whether the combination exhausts his entire income. 10 multiplied with 1, amount spent on good X. 5 multiplied with 2, money spent on good Y. Total money spent on both the goods is 20 rupees. This is less than his income. He cannot be in equilibrium. The consumer has to try a new combination. In doing so, he can consume one more unit of either of the two goods. Let us assume he consumes the second unit of good X. Once again, MUY by PY becomes greater than mux by px. This inequality makes him to consume the third unit of good y. 8 equal to 8. Equilibrium condition is satisfied. But the amount spent on these two goods is still less than his income. He spends only 35 rupees, but his income is 50 rupees. He does not exhaust his income. In his attempt to attain equilibrium, he moves further. At last, he reaches the combination 3 units of good x and 4 units of good y. In this case, mux by px equal to muy by py. The first condition is satisfied. Marginal utilities of both the goods are diminishing. Second condition is satisfied. He spends 30 rupees on good x and 20 rupees on good y. It exhausts his entire income. Third condition is also satisfied. His total utility is maximum. Utility from good x 90 plus 80 plus 70 240 units. Utility from good y 50 plus 45 plus 40 plus 35 170 units. Total utility 240 plus 170 410 units. Given the utility schedule, income of the consumer and prices of the two goods, 3 units of good x and 4 units of good y is the equilibrium combination. 410 units is the maximum total utility that our consumer can get. No other combination will bring him as much total utility as this one. Once the equilibrium is reached, the consumer will neither go for a new combination nor prefer a reallocation in his budget. We shall discuss consumer equilibrium graphically in the next lesson.